Good afternoon. Thank you very much for joining us for this conference. We're, like we have said today at numerous occasions, very happy to see so many of you in person. So curious and so enthusiastic to listen to our projects and to ask your questions. I will first introduce myself. My name is Anka Pashka. I'm a project officer working in SINEA, the European Commission agency managing the transport projects, among others. And part of my responsibility day to day is to manage some of the road safety projects. So this is why I'm here today with this wonderful panel of people that have been implementing road safety projects for us in the past 3 years. Before I give the floor to them, I just kindly like to remember one of the safety measures which we recommend you to adopt, and which is to wear masks at all moments when you don't speak. And this being said, I'll kindly remind you that this session is looking at the protection of road users. So it's a session in which we will present the results of our projects working on road safety. Like you all know, in terms of road safety, the European Union has set itself a target of 50% reduction of the road deaths, and also, for the first time, of the serious injuries by 2030. This was set in the Commission strategic plan for road safety and in the EU Road Safety Policy Framework 2021-2030. These documents also set out road safety plans aiming to reach zero road deaths by 2050, the Vision Zero, and setting out key performance indicators. However, despite the improvement in road safety in the recent years, road accidents and their consequences remain a serious social problem. Yesterday, the European Commission has published the preliminary figures on road fatalities for 2021. You have probably heard that an estimated 19,800 people have been killed in road crashes in the last year. As traffic levels return to normality, more than ever, we must ensure that we don't return to pre-pandemic numbers of deaths on our roads, because we believe that every death and serious injury on our roads is avoidable. So through the dedicated calls on road safety from the program Horizon 2020, we aim to contribute to this reduction and to help deliver the safe system approach of safer infrastructure, safer vehicles, safer road use, and better post-crash care. The 3 projects that we'll speak today integrate into the overall objective of safer vehicles, road and roadsides. And saying this, I will give the floor without waiting to our first speaker, who is Werner Leitgeb, who is a lead researcher for Occupant vehicle and battery crash safety at Virtual Vehicle Research in Graz, Austria. So, Werner, the floor is yours.
Thank you very much, Anka. Good afternoon, everybody. I hope you can hear me, and that's good. I'm happy to be here, as was mentioned already several times today. We are all happy to be here, it seems. And yeah, I'm happy to present OSCAR project that was running for the last 3.5 years. It's one of the first projects today, I think, that has already finished. My talk is about 50 minutes. I'm from Virtual Vehicle Research Center in Graz in Austria. And yeah, agenda for today. Everything fine?
I'm not sure if we can hear you so well.
Can you hear me now?
Yeah.
Oh, I'm too tall maybe. I will do my best. Okay. Agenda for today, overall project presentation about the consortium and about our objectives. Then I will focus on results. This is a 3.5-year project, so lots of results to be expected. Not everything will be covered here today. And then I will also talk about impact that we aimed to generate and that we will aim to generate in the near future. We were a project with 21 partners all over Europe, from OEMs to Tier 1 to research entities, and the project was run for 42 months from originally planned 36 months, but due to COVID implications we had to extend a little bit. Thanks for granting this extension. And we had a budget, EU funding budget of close to 7 million euros and around 7.6 million euros in total. Action points for OSCA. Overall, it's about occupant safety in future crashes in cars. So we needed to understand the future mixed traffic accident scenarios. Important of mixed traffic, it's not about AV vehicles alone, it's not about current vehicles alone, it's mixed traffic. In this context, we needed to address the continuous and complete accident phase from pre-crash to in-crash. We heard today already a little bit, or just below in the last session, we need to consider heterogeneity of our occupants. We are not all the same. We are all not all my size. We are all not your size. We are a rather large and very diverse set of people. And we need to derive restraint principles, restraint systems for our future and AV-enabled seating. And yeah, in order to do that, we also had our action point in preparing for virtual testing and homologation in order to cope with all this future amount of safety assessment needs and homologation needs. Therefore, OSCA's main objective, understanding future accident scenarios, demonstrating new advanced protection principles, looking into the diverse omnidirectional biofidelic and robust HBMs as one solution for assessing occupant safety and future occupant safety, next to the currently used crash test dummies and all well-known crash test dummies. Then establish an integrated virtual assessment framework so that we can address complex scenarios for in-crash, pre-crash and mixed traffic scenarios. And to do all that, establish standardizations, paving the way for standardizations for virtual testing procedures that entail and incorporate HBMs and future aspects on all of this. You will notice this is all still very much ongoing work, and the world is getting a big step closer to that. And yeah, as this is an European RIA project and also focusing very much on fostering the European industry on that, also here develop an exploitation strategy on implementation of all our results, virtual testing and methods in this context. Okay, that's what I'm going to talk about today. Just as a summary here, the first part, future remaining crashes in mixed traffic scenarios. There, amongst others, some of our highlights, we were able to simulate future traffic scenarios, not only doing accident research based on already happened accidents, but really looking into the future. Therefore, an open source tool was further developed based on CoWise and OpenPass. Can be downloaded, can be looked at, and can be used by everybody here for further work. In this context, for example, we were simulating 50 million vehicles, leading to about 2,000 crashes. And from that and lots of other simulations on, we were able to predict some of the more relevant future accident scenarios that are going to happen and are relevant for future vehicles. And those are mostly crossing scenarios. So we're talking here about the straight crossing path scenario and the left turn across path scenario that, apart from what we currently do and what we currently need, will be the main challenges to address. Just think about sitting in a car and being hit perpendicular to your side or to the other side. So you're not loading the current restraints accordingly, and not optimally protected. And in this context, OSCA was also able to develop a lot of generic pulses based on state-of-the-art vehicle models that are also free for use and can be downloaded and used here. Next point, I would like to talk about advanced protection principles we were looking at. 6 of them with lots of subgroups, even more diversifying our results here. We were looking at pre-rotated seats, seat inertia, so turning people back into principal direction of force direction. Looking at very heavily reclined occupant positions up to sleeping positions for, as you can see here, a very diverse set of people from very obese to very small, even very small Asian female people, so really smaller of the smaller and going up to the bigger of the bigger ones. Looking at some kind of living room conditions, having active seat backrests in our vehicles or in our models mostly. And we were also looking at the far side load case that especially Euro NCAP is focusing currently on. All these protection principles were looked at using advanced state-of-the-art human body models. In some cases, or in many cases, models that were even further developed within OSCA project. In order to continuously assess occupant safety, you need some kind of tool, some kind of strategy, some kind of method on how to do that. So therefore, OSCA was able to develop a positioning tool that can sit all kinds of, or nearly all kinds of HPMs into a standardized or a specific seating position. This tool is available for download for use based on Piper, a former European project. Then we are able to provide a kinematic transition from pre and in crash, not only for my finite element models, but also for multi-body to finite element models for those simulation freaks amongst you, a rather complicated and important stuff, benefiting from different calculation speed here. And we were also able to provide a homologation test case, a comparison test case that compared occupant model capabilities using 3 different solvers and 6 different HPMs in 2 scenarios, pre and in crash here. So a rather broad portfolio of use cases that can be further worked on and further looked at in future projects and directly go into development here. Colleagues of us worked on virtual testing procedures, building originally on Inviter projects from many years back for those long-term virtual testing applicants here. Very important, virtual testing will not substitute testing. So there will always be physical crash tests for validating models, for understanding basic feasibility, but we will need virtual testing in order to look at the diverse occupants, where crash test dummies simply go into their limits for new seating positions, where current crash test dummies simply go into their limits. So we provide here a method how virtual testing can be applied in the future, and I really invite you to go into detail and look into detail how this is going to look like, and most likely in this or a very similar fashion will be adopted by Euro NCAP in the next couple of years. Part of this was amongst others some physical testing, and in this case a very reclined position with a tour dummy done at bust in this case here. And important parts here for virtual testing: assessment of injury risks and homologation test case concepts here. And last but not least, I already mentioned before, we were updating, introducing methods beyond state-of-the-art tools and methods to the currently available, I always like to call it fleet of HPMs. Astrid is going to talk more about this topic later on. And this specifically on the topic of active HPMs that are able to behave human-like in the pre-crash phase, so an automated vehicle or ADAS-equipped vehicle doing an emergency braking or evasive steering. So these are models that can behave correctly or human-like in this context. Then colleagues were working on representation of skin, muscle, and fat tissue. So this is stuff that ordinary crash test dummies do not even have. Improving models in this direction. Then we were working on population heterogeneity and multidirectional biofatality aspects. And last but not least, and maybe the most critical point for the application of crash test dummies, for HBMs, improving and finding standardized injury criteria that can be applied everywhere here. So, diverse HBMs in respect to age, sex, stature, and weight were applied and further developed. We have a public available validation catalog for HBM, for active HBMs that were validated with the current models already and can be used by everybody out in the field. Injury criteria were updated in respect to rib fracture, analysis, harmonization, neck injury, and muscle injury. Soft tissue modeling was done, neck modeling was done, and lumbar, spine, and IVD modeling progress and extensions were we were able to provide here as well. Summarizing, as this project is already finished, lots of publications. Please visit oscarproject.eu media publications for the complete list and the direct links here. We have 20 plus public deliverables out of OSCAR. We're proud to that. Most of them will be available due soon after EU accepts them. We are currently in the finalization of this topic here. Follow us on this aspect, please, on LinkedIn and Twitter. We're going to update any news on that as well. And I'm not going through all the data and models that we provide open access for all of you at the different locations here, amongst others OpenVT platform that also Astrid is going to talk about later on. Please go through all this list here. Visit us, visit those data, those models, those methods. They can be very much applied and useful. OSCAR was doing lots of cooperation work in its 3.5-year project. Close cooperation with virtual project. Lots of international workshops on virtual testing and these kind of things. Integrating later on with SafeUp and HeadStart project. And we also plan to transfer data knowledge and whatever is needed and can be further used for the future Horizon Europe initiatives. Some of them, the more likely ones are mentioned here. The first one is already in grant agreement preparation phase, and we expect the one or other transfer and knowledge transfer here. We also had international cooperation, specifically with the US in respect of TRC and our ARCADS project that are working in a similar field of automated vehicle safety in this context. Then EuroNCAP virtual testing group and EuroNCAP HPM for virtual testing groups here led by ASEA and EuroNCAP. Exchange with NHTSA and IHS in the US. We had a parallel OSCAR China project running that was funded through the EU-China co-funding mechanism. I'm very proud that this had happened and happened successfully. And yeah, lots of international cooperation with university in the US and Japan here. Thanks for those making this happen. Areas of impact, future relevant accident scenarios, our open path tool and generic pulses that can and are already used outside OSCAR and further used on that. The occupant protection principles that we were developing are currently being applied and implemented at OEM and Tier 1 level. And of course, our models and data are used for academic and scientific use. And HPM updates are currently implemented at the different levels, at different sites, and also here lots of progress can be expected. Standardization of virtual testing, I already mentioned, going mostly into Euro NCAP initiatives currently. We'll see it in addition to that, and in the long term, future type approval is going to benefit hugely from our efforts here. And as Anka already mentioned before, the long-term goal of reduction of number of road fatalities and severity of injuries is helped by Oscar's results here. Last but not least, questions that you specifically asked for, what is needed in future research. We have a huge gap still for certifying HPMs for definite application. This is the next critical step for virtual validation in virtual testing here. Injury assessment harmonization was mentioned already, and future AV occupant safety assessment harmonization and goals for that are still needed here. Market uptake, I think I mentioned before, OEMs and tier ones already using that. And all kinds of Green Deal, smart energy, and 2.0 and CCAM initiatives are currently benefiting here. And we're hoping for virtual testing activities being implemented there. Apart from that, our consortium, partners from our consortium are currently involved in upcoming European initiatives. I mentioned that before. And if anyone here or from the other partners, colleagues of yours, need more information, want to specifically participate and benefit from our results, please visit our webpage, use our email address. It's going to run for the next couple of years for sure. And benefit from all this large amount of deliverables we were able to provide here. Last but not least, what's the benefit of Oscar? It was a 3.5-year project with 7 million euros of funding. Main benefit from my point of view, without such funding, it's impossible to gather such a large consortium, to gather resources for such a large endeavor. Bringing those people together for so long time and really focusing and working together and bringing this topic of virtual testing applications to the market. So I think without these kind of fundings, industry would find it hard to organize, and universities and research centers as well. So thanks for that. It's possible to come up with these kind of things. Thanks a lot. Took me a little bit longer than expected, I think, but less questions afterwards. Thanks a lot.
Thank you very much, Werner. That was very interesting, and indeed, thank you for pointing out that our role here is also to work together and to share our knowledge and our experiences. I will give now the floor to our next speaker, Astrid Linder, who is Professor of Traffic Safety at the Swedish National Road and Transport Research Institute, VTI, and an adjunct professor of injury prevention at Chalmers University in Sweden. Astrid, the floor is yours.
Thank you very much, and thank you for this opportunity to talk about this great initiative that we have been given the opportunity to have. It's the virtual project, and I'm the coordinator. And virtual project, the whole title is Open Access Virtual Testing Protocol for Enhanced Road User Safety. And the topic was addressing all road users. So we had we have a clear focus on all road users and also not only fatalities but injuries and severe injuries in terms of also addressing disabling injuries. And when it comes to occupants, this is the most common and costly injury is, as some of you might be aware of, the whiplash injury, the soft tissue neck injury that occurs in low velocities. So you will hear more about this one later, because this is one of our test cases where we actually take the whole chain from the virtual models to the physical models and show all the steps in the chain. So we started in 2018 and we will end this year. If we get the extension that we are applying for, we will end a bit later this year, but it will be within this year. We have a budget of 7 million euros, and of course a website that you can look into if you find this interesting. We are 15 partners around Europe, and we have a rather equal split between academies, institutes, SMEs, and companies. So you see here from the chart that we have the bigger university, but also big companies such as Siemens, Volvo, and Faurecia. So and Dorel, I should also mention. So we applied. We looked at what we wanted to achieve, and then we picked the partners that could make this happen. Our overall goal is to, of course, then reduce loss of life and health in road crashes. So this is about the crashes that occur. We in this tool chain that we have developed, we also look at how to avoid crashes and the effect of that. But we know that for the foreseeable future we will have crashes that occur, and the question is how best to develop the safety systems, and that will be then the passive safety systems, so that we don't lose our life and health. We aim at identify protection protection by using virtual testing and human body models. You heard already a lot about human body models from Werner, and thank you, Werner, for having introduced many of the topics that comes here, so you will hear it again and it will feel more familiar to you. And we do this by taking a totally new approach when it comes to the norm and the models of the human that we use. As you have seen earlier today also, our norm is the average male, and we have a small female and a large male to cover the range in terms of height and weight. However, we have until now been missing the average female. So our approach is to have an average female and an average male human body model as the starting point, so that they always come in a pair. They are designed using the same setup of data, the same modeling approach, and from there we can vary height, weight, age, and so on. So this is the starting point for this project. In addition, we also have a strong aim to share and foster knowledge. So we decided to do this all open source. So this has been a fantastic force in the project, keeping up a fantastic spirit, and have avoided us from going down the track of who is owning this and how could we share it, because we know that what we do, we will share with the whole world. And I'll show you how. Of course, these 15 partners is not enough. So we have a big international collaboration with universities, organizations around the globe. And here I can highlight in particular Uptake, where we get the base data for our human body models of the average female and the average male, because such data exists. It's only that we have so far used the male data, and we do both. Also, Insurance Institute for Highway Safety, I want to highlight, because they play a very important role in the US, very quite similar, or with some similarities to your NCAP here, with being very active in when it comes to testing and addressing what they see as needs from the insurance perspective. And then coming to Europe, want to highlight, of course, Euro NCAP, that is an associate partner that we work with in close collaboration throughout the whole project, and French car manufacturers and Toyota. And then going to Japan, we have Yari, and all the way down then around the globe to Australia, where we collaborate with and got data from the world's largest tram network, because we also look at occupants in public transport. So we are organized quite traditionally. We have the work package 1, where we do all the infrastructure, where we are sharing our everything that we do. And this is also where this open VT is established, where Oscar have placed some of its material. We have work package 2, where we develop our human body models, and that is models with skeleton and all soft parts and so on, as we humans consist of, in contrast to dummy models, which represent parts of plastic and metal and so on. And then we have our 3 use cases: the occupant in the vehicle, the vulnerable road users, cyclists and pedestrians, and then work package 5, passengers in public transport. Then in addition, we have a whole work package for cost-benefit analysis. So we provide, from our simulations, input to a cost-benefit analysis tool that has been created to assess the results in terms of cost and benefits. So, of course, we started off with doing an extensive literature review of the different road users in the vehicles, vulnerable road users, cyclists and pedestrians, and also standing occupant in public transport, which is our focus here. And from there, we identified the most common injuries and the type, the frequencies, and ensuring that we are addressing something that we know is a challenge today, and that is highly likely to be a challenge also tomorrow. As I already mentioned, our way to make this available is that we established an open VT platform, and it's on the GitLab server. Everybody can access there, and you find what I show today, and much more, of course, here. What should I think that's it. I will dig deep down into the human body models directly. Of course, we have, as Werner also explained, we are looking at injury, functions, criteria, all tools, and so on. So I would just give you a few highlights from the project, so that you don't think I cover everything here. The human body models, we call them Viva Plus models of an average male and an average female. You see them here side by side, and you also see the different in proportion in terms on the red and the blue occupant. So there you see the difference that this average make. Broader than that, the tools, of course, the occupants model are then made into standing occupants. The standing occupant is also made so that it can sit on a bicycle. So we have developed a bicycle so that we can look at different bicycle postures and see what is the most severe in terms of postures. Let's see, do you have a cursor? Yeah, I have it here. You see it? Yeah, excellent. Okay, we also have a simplified structure of a vehicle for the pedestrian. For the pedestrian also we have a shoe that you need. We also develop open source seat models. This is seat models where we have had done volunteer tests, low severity testing. So this is some seat model, open source, that can be used to assess different human body models that you want to use in a test, in a virtual testing. Also, we have a seat model of an Toyota Yaris, where there is a lot of data on performing, how it's performed, in particular in rear impact and how it protects the occupant. And we also address children, so there are a number of child seats that you can use. Going then to the occupant, standing occupant in public transport. Here you see an interior for a tram, I think it was, or a bus. And also we have a contour of a tram. And then I told you about the whole chain. And here we go for the seated occupant, low severity crashes. We have made both. We have made actually physical seat evaluation tools that are models of the human that for assessing the safety of the injury protection performances of the seats. So here I will show you the Viva Plus model, the average female, in a rear impact in the Toyota seat. So this is an example of the tools that are available that everybody can access and improve and be part of this big community. Here you also see actually the first picture of the seat evaluation tool, the physical one, that is now being put together and is doing its first test. We will have an equivalent set. Here you see that it's the average female, also of the average male, and starting to build our knowledge on this platform. So, looking at the volunteer test, or the standing occupant in public transport, there we looked in particular to how you maintain balance when you are on a moving platform. And looking at normal driving, not emergency events, but under normal driving, like takeoff and braking, because there we saw from the injury statistics, and this one was from Melbourne, from this big trams system, that there were actually injuries caused during normal takeoff and braking. So we did a series of volunteer tests to identify what motion patterns that are the most efficient in terms of maintaining balance, as an example. And then we took the data further on into the simulations, first working with OpenSim to look at the motion broadly, and then into these, actually these are active muscles, models that also Werner told you about, that respond to the motion. Here, just to show you that the cost-benefit analysis tool is available, and that you can use this and impact or put your input into it, and of course improve and so on. cross-project collaboration. We have had the fortune of being 3 projects that were funded in the same, under the same scheme, and we have benefited a lot from that. We have had 3 events. First, we had a virtual Oscar Pioneer event, and then we had 2 virtual and Oscar workshops where we actually were able to gather globally the stakeholders here and have your NCAP, Toyota with the thumbs model, and Insurance Institute for Highway Safety as an example, to show and describe where they are. And actually, during this project, the thumbs models were made publicly available. Before, they were only available if you paid a fee. So yeah, that was some example. Cross-project collaboration and impact. Here you see that Oscar Group down there in the list, they have some material here, and also already your NCAP have put some material on our OpenVT. Of course, a lot of scientific publications. These are all the peer-reviewed gold open access publications, and in addition to this, a large number of presentations and yeah, other events. Finally, then, to impact. You might be aware of that we have now an ad hoc group within the UNECE, which aim at looking at diversity of occupants and how the testing can reflect the population more broadly than it does today. Because in the regulatory test, as you might be aware, the requirement is that you use the average male. We also have your NCAP aiming at, is to my knowledge, that they have set the date now for 2029 to go into virtual testing as a complement to physical test. And then a question that we already knew from the start would come. What do we do when the project is over? How do we make this alive still after the project? So we have established an organization, the OpenVT organization. It is situated in Switzerland, Zurich, and it's the starting point for taking this further than we will be able to do within the project. So with that, if you have further questions after this day, please don't hesitate to contact me. Thank you for your attention.
Thank you very much, Astrid, for your impressive presentation of the work and also for the passion with which you shared it with us. I will now give the floor without waiting to Núria Pereira, that works at Plus IDIADA in the active safety area. She has been involved in research and development activities related to passive and active safety since a number of years, and you could hear her also earlier presenting another project in the connected automotive section, SafeUp. But here she will present us the project Pioneers.
Thank you, Anka. Good afternoon, everyone. I'm Núria Pereira, as Anka said. I'm here presenting the Pioneers project on behalf of my colleagues Enric and Marta Tovar, who were the coordinators of the project, and they couldn't attend today. So the Pioneers project started in May 2018, and due to COVID reasons, it was extended and ended October 2021. It has a budget funding of 5 million. And the consortium's partners were 16. There were a diversity of partners from research institutes to OEMs of motorcycles, as well developers of equipment, of protective equipment, and as well universities and industrial partners and automobilists clubs. The objective of the projects was to study the most critical safety accident scenarios and developing methods and strategies to ensure safety futures for the future, as well developing injury criteria to assess better the injury risk that could happen on those accidents and study the most critical body regions. As well, there were designing test methods, virtual and physical, and were updated and improved to have a better repeatability and reliability, and to assess better the future systems and have a better impact conditions, and as well those results to be able to be included in standardization groups. As well, another objective was to improve the requirements that needed the protective equipment and as well the onboard systems to have a better protection of the rider who was using it. And as well to develop new protective equipment for the riders and as well onboard safety systems that were developed in the project. Regarding this as well, there were designing tools and products to better the requirements of those developed systems and to be able to set a minimum of requirements that needed to have those equipments and to use it for telling to the final user the differences of between equipments that given better protection to the user and from others that given lower level. So in this way, the user could assess the use of those products. So the activities that were carried out in the project were ankle protection. And this area, IDIADA designed a new method to assess the performance of the boots and the reinforcements of the boots. And a study was done to cover all this data. For the torso protection and airbag, IDIADA and IFTAR designed a new method, and it was improved. There was already existing one, and what they did was to make the test more severe. So in that way, it was forced to improve the development of those systems. And those data was included in a working group, so they could be included in new future standards. There was another area of research, the garment research. It was done a study on the injuries of tissues, and as well it was studied the economical costs that happened in the area. Those garments developed a new methodology where it was studied the temperature rise of the fabric during the testing, and as well the parameters and variables that were given for those methods. The goal of this technology was to give a method to measure the impact force and the whole formation of the fabric during an abrasive slide, and to be able to compare it with real data world. The head and neck, it was a study of the helmet, and it was even a method that was improved with new impact conditions to have a better assessment of those helmets, then a way to improve the safety and improve the helmets that were on the market as well. This way, it was also a study on neck braces, and it was done a geometrical assessment of the helmet and the neck braces. This was a study that was not done before. And using this study, helmet braced fit, that was possible, enabled to be able to be further studied in future projects. On the way of talking about the motorcycles, Piaggio studied the safety of the leg cover The leg cover was used to mitigate small shocks and wounds that were done in urban scenarios where there were slow velocity and there were really crowded, like traffic jams. They were started with a simulation to design the process of the cover. And then they simulated with a pendulum test to evaluate the performances. And then there was carry out a really full crash test where the virtual simulation was compared with the full crash test to have reliable data. Another way, Ducati studied the lateral airbags that were developed in the project. These airbags were in the laterals and were designed to protect the injuries that suffer the rider on lower limbs, like the legs. And it were specified for impacts with low speed and avoid lateral impacts. The same as the Piaggio motorcycle. Here in the Ducati, it was the installation inside a real motorcycle. Then there were simulations to study the behavior of this development with the airbag, and then finally was a real full crash test to correlate the results with real data with simulation data. On the pre-crash braking, there was included in a real motorbike, so participants, volunteers, make it tests with this pre-crash braking motorcycle. The results were 100% positive. Some participants reported problems about the maneuvers and control of the motorbike, but the majority of the results were positive. So due to that, it was encouraged to keep testing with this kind of motorbike and methodology. And as well, there in this project was a development of communication between the motorcycle and the protective equipment of the rider. It was developed an algorithm, and with the specified technology that was implemented, it worked all together quite well, the system. Requirements were defined, and security as well was developed. But the system overall was well implemented, and there were 3 airbag jackets vendors that showed interest in implementation this system in their jackets. The vision of this project was to reduce the number of accidents and injury and fatalities on power two-wheelers. What they wanted to do, in order to do that, they wanted to increase the performances, the usage, and the comfort of the personal protective equipment, and as well to introduce new onboard systems devices on the motorbikes. The expected impact was to understand the injuries that had the riders, the severity that they had, and the regions where they happened. Increase the performance of the safety systems, improve the methods, and increase the usage between the riders of the personal protective equipment. And thank you. Sorry for this short presentation. And if you have any other questions, please send an email to Enrique Soriano, who is the project coordinator. As well, the website is working, and they had several demonstrators done in October this year. So all the information is online and available. And thank you very much.
Thank you very much, Nuria. And now I will give the floor to Peter Urban, who doesn't really need an introduction in this room and in this sector, I think, but I'll still say that you're vice director at IKEA Hermitage Aachen, and he will drive us through the question and answer session. We have 14 minutes for that. Peter.
Yeah, thank you very much, Anke, for that short introduction. I think that was indeed a very interesting session, and as it was said before, while crashes will still happen also in future with growing levels of automation, so it's good that we prepare somehow for that. The projects that we have heard about had a certain focus, I think, on virtual testing and virtual assessment technologies and the further development, in particular human body models. And also with the discussion that we had in another session today, I think it was very nice to hear that projects really had a focus on covering all road users, covering the heterogeneous rider-driver population or road user population that we actually have on our roads. Also, the application to new sitting positions in future automated vehicles, I think, is a very nice perspective towards the future and the use of the results that we have seen. And the same, I think, also applies to the safety of powered two-wheelers, where there's still a lot to do. You probably know that powered two-wheeler riders are, while using our roads, under a very high risk of being injured or even killed, and therefore it makes a lot of sense to further develop testing methods and also further develop safety systems for these riders, as has been presented. But I'm at the same time quite convinced that there's still some questions that you may have, and therefore I would like to invite you to ask your questions and direct them towards our speakers today. Yeah?
Hi, everyone. Sorry, I will once again make a question about disability and how easily it is to configure or reconfigure your biofidelity models or your virtual models and the assumptions behind the simulations to cater for the physiology and the behavioral patterns of people with disabilities, because we know they don't have the same reaction, sometimes they don't hear, they can't see, so how easily it is to reconfigure your models for them?
I can start.
Yeah.
And I got this question about, but now when you have done this model, what remains? And a lot remains. Because it's about giving these models the properties, exactly as you say. So we have started now with in the virtual project with addressing females at all. At all. So first we need a model that represents that part of the population together with the male part of the population. Then you can start to elaborate on the details. But if you don't have the model at all, so this is what, the starting point that we have provided, and that we have together also here provided different tools to start this endeavor, I would say, where we have this possibility to look into this and implement it. So it's not more difficult to implement properties of a specific kind. It's about finding out what is it, how does it manifest itself in the model, and then implement it. And then you need to do the research. You need to quantify this. What is it that you should model, and how should it be done differently? And should it be done differently? Because sometimes I get the question about females and males, what is the difference? Yeah, there are also very many similarities. So it's not that you need to do everything different. And that depends on the crash or the circumstances. So for example, a disability when it comes to the leg doesn't necessarily have any impact on the loading on your neck. So yeah, just to show you the complexity. So what we have done here is to make a starting point to go into this direction.
Maybe to add to that, I think virtual testing is the only way to actually implement any kind of assessment, any kind of modeling of out of the norm, whatever it is. Doesn't need to be even be people, but in order to go broad, you need to do it virtually in current days. We cannot build a crash test dummy, a certified one, for a certain disability. but you can do a virtual model of it. Definitely, and Astrid for sure can. Yeah, but that's the real point. What's the real hard part that comes, as Astrid already said, is we have to find or cluster this kind of needs, these groups, but we can model them. And these methodologies we are developing and we're developing for sure need more work, and in some areas even more work on that. But the basis is here, and adapting, not sure what kind of disabilities you are focusing on. There are many. But what we always say is we are about 8 billion people on the world, and all of us have different requirements on safety. We will not be able to focus on everybody, because that's you can do retrospectively after accident, but it's too late most of the time. So we have to find and cluster this kind of group of people that is relevant, sufficiently big, and can be addressed. The same is for vehicles. If you look at vehicles for disabled people, they also have different requirements. But with these kinds of tools, you can develop them, and you can develop safety for them and specifically for them. So I think this is, yeah, as I said, the only way to address those aspects, and a good way to do so.
I keep that, that's extendable.
Everything is extendable.
Good. You would expect my code. Thank you.
Maybe one question from my side also to you, Werner. One of the nice things that I take with me from that session is that there is good use of the cooperation or collaboration opportunities that are there. And I think it became quite clear that this worked very well within these European projects here. But you also put some emphasis on the international cooperation activities that you did. Could you comment a little bit also on the good and bad things that you experienced there?
No bad comments. No. The most important thing is, as you said, international collaboration is the only way in this field to move forward, because we are all relying on each other research work. Europe is doing not all the research work that the US is doing. The US is currently building a lot of knowledge on especially the vulnerable road user part we do here in Europe. So there's a lot of needs and cooperation needs here. What was very difficult in the beginning of OSCAR is find any kind of collaboration with the US, because they were kind of locked in the last couple of years in the previous presidency. So there was, I do not want to even comment on that, but it was a fact. There was hardly any response to be received. On the other hand, we managed to do a research cooperation with colleagues in China. We had a parallel OSCAR project in China established, that was established back then under the European Chinese co-funding mechanism. The good thing is it happened. The not so good thing is there wasn't really a process on how to do that, so we had to figure out all this first. And not wanting to comment here on political decisions in general, but this aspect is removed from current European Horizon Europe goals. And I'm not sure if this is the best solution in these safety topics, because it's about safety, people's well-being, and a lot of good collaboration can be had in these fields as well. So I was kind of surprised, but some kind of collaboration will follow on here as well. So I'm kind of positive on that.
Yeah, thank you. Indeed, I guess in this area we share a common interest in protecting people's lives, indeed. Yeah.
Do you mind if I do another one question? But did you find in your collaboration anything in terms of the content, not the process of the collaboration? The content with the Chinese, was there any differences or that are worth thinking about?
Difference in humans are the same here and there, and accidents in China are slightly different than in Europe because their roads are different, and but in general the approaches are similar. Asians are generally smaller, not all of them, but and so the methods are similar and the approaches are similar. Their way of thinking is also not very different. So, at least in our field of research and science here, we are all the same. There is no. The hair color is not important for crash safety. For other things, yes, it is. But for crash safety, it's physics, and yeah, you know much more about.
It's physics.
About in the end, it's physics. Yeah, no, not really.
Okay, I was just told that there is a question that I couldn't see here. Sorry.
Yeah, talking about China, I'm humble enough to squeeze in my own experiences. I've interviewed people about cars and also with a focus on gender. And I mean, my experience was that many of these Chinese women said, I don't want to sit in these big, bulky cars, thinking of, you know, the most recent Volvo. For example, so I think that producers could learn a lot also from introducing gender here. And another, perhaps, anecdote was that Volvo was bought by a Chinese company, Geely, and they wanted to develop these more fancy cars. And this was really against the Swedish guys who said, oh, we want to keep our underplayed masculinity. Underplayed masculinity. So I think that these ideas of gender and, you know, stereotypes perhaps should be included, perhaps even in the safety stuff. Thank you.
Yeah, I think that goes a little bit beyond the safety research topics, even towards the marketing activities of industry. But yeah, thanks for the comment. I think since we only have 1 minute left and you only have 5 minutes in order to join the next session, I think Anka.
We can have 5 more minutes. I've heard from the other sessions is similar.
Okay. Yeah, thanks, Mazena, for giving us some opportunity to continue the discussion. Yeah, so if there's any other question, any more things that you would like to know from our speakers, please raise your hand. Magnus?
Yes, Magnus Granström, Safer Platform. Thank you, all three of you. Very good presentations. A question regarding the two-wheelers. When you want to continue on this work, how do you look at one-wheelers, three-wheelers, and of course e-scooters?
Okay, thank you for the question. I'm aware that the consortium from Pioneers wants to keep working on the issues regarding protective and onboard systems. So I think that in future calls, maybe if it's possible, they will try to have another proposal on working that topic. So that's for sure. They will keep working on that. And regarding e-scooters, I know that there are proposals for the next calls that are involving e-scooters and new mobility. So for sure, we will have work on that and results on this very soon.
Yeah, and by the way, if you are interested in discussions about future research priorities in that area of road safety, you're also very welcome to join the ADTRAC working group on road safety, in which such things are discussed and then recommended towards the European Commission. So, well, please let me know if you would like to join that group as well. Yeah, with this, I think we should probably close the session then. Anka, would you like to say a
Perfect.
few words?
No, not much to say. To thank you all for the active participation, for your attention as well, and to invite you to attend the next session that will be held in this room. It's new future and inclusive mobility patterns, in which we will learn about the gender and we will learn about new values that our mobility could have. So that will be starting then, I understand, at 5:25, so that we have 5 minutes break. Thank you all.